Hi, welcome back. So in the previous video, we showed an Ansible playbook generating these two machines, a web server and app server, and running through the playbook to make them all patched and configured as desired. Now we're going to go through and I'm just going to rerun that playbook again, but this time I'm going to show scaling up, scaling down. So what I like to do is let's add two web servers. Sorry, let's make sure we have a total of two web servers. We're going to leave the app server alone, and we're going to set up a database server. So we're going to have a total of four machines in our output here, ignoring the terminated one. So let's run that again. So again, the output shows we've got two web, an app server, and a database server. And it's now in the process down here of building the VMs. So if we do a refresh of the Amazon console here, we see that it does have another in a pending state. There, the web server should be there. So we got two web servers now. And we can see here that it didn't have to set up any more app servers since we left the number at one. It already had one, so it just went on. It is now in the process of building up our database server. The nice thing about Ansible, when it defines these, is that when they're added to that group, we've also got some tags. So the role that we defined each of these machines in is based on the group name. So if we end up wanting to target our scripts, our playbooks to only do a patch or install a piece of software on the app servers, we just target the app servers group, and that magically would only target that, in this case, the one box that we have. So it's now going through all of those machines. As you see here, it's got all four of the EC2 images plus the two local VMs, and where the two VMs from the previous demonstration were not modified or anything. They are still green, and of course we got the patching and updates that the stigging requires being done on the two new boxes. So that is coming along. So basically, there we go. We see all four of those running. One of the nice things with the playbook, where it does have those groups that we've set up, so in the case of a web server, it would be possible then to use the hosts, the information about those machines in the web server group, and dynamically go and update a configuration on a load balancer. So as you built machines into the cluster, the playbook could also, if it had the right permissions, get in onto the load balancer and add and remove machines so that the load balancing was seamless. So you could do things instead of having to patch a set of servers and keep those machines around forever and ever. You could actually get into the habit of building brand new ones that are configured exactly the same as they should, and with all the latest security patches and whatnot applied from day one, and then add them into the cluster and pull out the oldest one and destroy it, so that you don't have any exposure left over from an old machine that might have had a configuration or something like that left around. So it's still finishing up the stigging process. That should be completed here shortly. But we'll see that it will then go through, and again, those new machines that were built in EC2, they have a few changes that need to be done on them, but the other machines shouldn't have anything to really do at all. After it's done stigging, it's going to go through and get these packages set up. So as before with the previous demonstration, a lot of the work that needs to be done doesn't have to be done on the existing boxes, but the new ones do need some work. So here we can see some of the installations it's doing here are only being necessarily need to be done on the new one. You might have noticed up here there was a play that all of the EC2 images got an update applied to them of some sort. That's something that we can look into the playbook. It might be a quirk with how those are. Uh, Nothing major, but the nice thing is where it is being done by Ansible, it's all consistent, so it should be very easy to reproduce and understand why, and then possibly update the bit of code that's necessary so it doesn't have to do it if it doesn't need to, or figure out why it's insisting on doing it every time. Now we're into the patching section. So again, the local VMs and the two initial EC2 images were fully patched up, and they don't have any need to install anything. Getting to the point where the other two, the new Amazon images, will probably denote their change. Now, one thing that I didn't show on this run, but we can go back and use a stopwatch to figure it out, is this whole process from the building the brand new VMs through to the end of having them stigged and patched and rebooted is only about 2.5 minutes. Very, very quick. Obviously, that time will be dependent on how complex the other parts of the playbook are, but in actuality, even a complex playbook probably isn't going to be an hour-long ordeal. So this is something that, if it was desired, could be run on an hourly basis if you wanted to. It could make sure that all these settings are still applied, and make sure patches are applied if you wanted to, things like that. So that would help ensure that the cluster systems are all fully up to date and configured properly. It'd be one way to do it. We run Ansible in check mode also, which doesn't make any changes, but it reports the green, yellow, red, so you get an output at the end. That's handy. So if you just want to watch for systems and understand that, if you waited a week and ran this again in check mode, it might show that you'd have some machines that need to be patched. So then you could schedule a patching at a later off hours time, or however you want to do that. So here we go. We got the systems. They got their output. They all ran again. So we can see the two physical boxes have an uptime of 30 some minutes. We see that the two initial EC2 images have been up for about 14 minutes. And we see the brand new ones have an uptime of 0 because they were rebooted, but they were patched and all that. And still have the four machines here. Last example is going to show the scaling down. So again, depending on your playbook and how you wrote it, you could have it take a lot of intelligence based on, is this a new machine or is this something going away? This playbook just simply is going to show the decommission process or destroying process. So by setting all these counts to 0, it will go through and destroy all of them. And I'll go ahead and get that started. The destroy process, at least the way the EC2 image is set up, is it does do a clean shutdown of the servers. So here we see the two web servers. They're going into shutdown state. So it does an OS shutdown. It would be possible to go through and modify the playbook so that instead of doing a shutdown on them, it might run some other chunk of the playbook before it does a shutdown. That's not demonstrated here. That would be a possibility to do. But the good thing here is it's in the process. It's terminated the two web servers. It's now shutting down the single app server that we had. And it's going to continue through. Now, these are doing OS shutdowns, so barring the OS hanging or whatever reason, if there's any cleanup it needed to do, that could be done by the system at that point too, if it was something that you didn't couldn't do in the Ansible playbook. So things you'd have the Ansible playbook do then after all this would be maybe go through and delete SSL certs or do another update to the asset tracking system, maybe register that that machine was destroyed at this time, so you had a good death certificate of the server, and keep assets tracked and tidy there. So there we go. We see it. All the VMs are terminated, and then the system playbook continues on through with the running of the playbook on the remaining servers, which are the two local boxes. So again, it's running the Stig script, and it's going to continue on through to the end here. It'll take another minute, but that's a demonstration of the potential to scale up and scale down the cluster servers with an Ansible playbook and in the cloud. Thanks a lot. And have any questions, just get a hold of me. Thanks.